To repeat myself. First person on the fourth row. What does the computer do when it executes your code? It does exactly what you tell it to do. Next person. If it is not doing what you think it should be doing, what does that mean? Because it is doing exactly what your code said to do. Every time, I guarantee it. So if it is not doing what you expect it to do, what does that mean?
An error in the code.
If it is not doing what you expect it to do, that means your code is wrong in some way, shape, or form. This takes us into debugging, because you have to debug your code, right? You have to figure out what you did, what you told the computer to do, that was not what you actually meant to tell it. So when you get values out that are incorrect, or summations out that are incorrect, or concatenations out that are incorrect, the simplest way, one of the simplest ways to debug things is by use of this printf statement. That's why that was the first thing we taught you. Well, the second thing. I taught you a little bit about types. But this is why one of the first things we teach you, which will indirectly answer the question about why we don't do projects, because you're nowhere near ready to do projects. Printf will help you determine the value of variables. Now printf has its own obstacles. You have to use the right format specifier with the right type. If you get that wrong, then that's a puzzler. You have to figure that out. But here's the answer. All cases of debugging is essentially the exercise of removing assumptions. You remove the assumption, for instance, if something isn't coming out right and you know the variable is correct, you are assuming you're using the right format specifier with the right variable type. That's an assumption. You could be wrong. How do we remove assumptions? We go look it up. We go find the answer. If I'm trying to print out a string, you have to go see what kind of variable a string goes into. We've touched on it a little bit. We're going to touch on it more. Oddly enough, when we get to arrays, what is a string? Who knows what a string is? What kind of variables does it go in? A string is a set of characters terminated by a null. That's the convention in C and C++. What kind of a variable does a string go into? An array of characters, a character array. That's exactly right. That is what a string goes into. So obviously a lot of you didn't know that, so that might be assumptions you're missing in your programs. Okay? But this is what debugging is. It's removing assumptions. One of the ways to remove assumptions is to use printf to see if it has if a variable has what you think it has. Okay? But there is no magic to there is no magic to debugging. You have to remove assumptions, which means the first thing you have to do is figure out what your assumptions are. And this is why programming is not for everyone. Most of us don't think that clearly, that linearly, and that finitely. By finite, I mean in small increments. Okay? But that's why you have to debug programs. So everybody comes up and asks me how to debug their program. I will not debug your program. I will grade your programs, but I will not debug them, because that is the essence of this class. And you either will be able to or you will not be able to. Or somewhere in between. It's not a Boolean, it's not true or false. It's a spectrum. Some people, it's obvious to them right away. Other people will never figure it out. And then there's everything in between. Okay? But this is the techniques for debugging your programs. First thing, to figure out it's not doing the right output. And for that you have to read the requirements. I updated the do while lab just now, and I updated the switch lab. I did not change the requirements, I just made them a little bit more clear. Because I don't always write the clearest things the first time out. They're somewhere in the first 10, I think. Neither is due yet, but one or both of them may be due this week, on Sunday. But remove assumptions is the key to debugging. To remove assumptions, you have to figure out what assumptions you made. That's the real trick, is to figure out what assumptions you made. Which means figuring out how you might be thinking incorrectly. You think you know something, and well, maybe I don't. That's a hard thing. I do it. Do I do it every day at work? I do it every week at work, either on my code or somebody else's code. I usually quickly find it, but I've been doing this for decades. Okay. If you have a lot of trouble with that exam, you should probably consider dropping the course. That is the easiest exam probably you've ever had in college. But it's certainly by far the easiest exam you'll ever have. I can't say that. You'll ever have in this class. And in data structures, for sure. And in any other programming class I teach, C++ or C#. That was an almost trivial exam. You saw how quickly some people turned it in. Right? Before I finished making the key, of course I was a little distracted. It took me, how long did it take me to make the key? It took me 12 minutes to make the key. Okay, I'll grade these exams, and we will go over them next week, first thing, and you'll get to keep the exam. I'll give them back to you and you can keep them. For loop. There are multiple kinds of loops that we're going to talk about. We're certainly going to talk about for loop. We may get to the while loop and the do while loop. We will also certainly get to certain aspects of what you can do with the loop. This is the format of a for loop. Okay? You have three parts separated by two semicolons. The first part is initialization, which is just a statement that gets executed. It doesn't even have to initialize anything to do with the for loop. It can be a statement that you just execute. It is almost always used to actually initialize the for loop. I'm going to show you the typical example in a moment. The continue condition. That is a Boolean condition that when evaluated, if true, the loop continues. And then finally, the increment statement, which, like the initialization statement, can be anything that you choose to put there, but is typically used to increment a controlling variable. But does not have to be. So let me give you the typical syntax . That will be your typical syntax of a for loop. Okay? You set I to some initial value, in this case 0. This statement is executed once and exactly once. Then the condition is evaluated. The fact that the condition is evaluated immediately after initialization means you may go through the for loop 0 times. It depends upon what the condition is. And then the increment statement, which again can be any statement, but is typically incrementing by 1 or 2 or whatever you're doing, and that's why it's called the increment statement, is typically incrementing the control variable. So let's suppose you had declared a C array up here. That code would simply initialize all entries to 10. First person, second row. If this array has 10 entries, what are the valid indexes of the array C? What's the first index of the array C? What value? What number index? What do all arrays start their index at? 0. Therefore, what is the highest index for this array C that has 10 entries? So 0 to 10? So the lowest index is 0 and the highest index is 10? Okay, let's just do the little experiment. And believe it or not, this is useful. Okay, that's 0. The highest index is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But I'm only supposed to have 10. So what's the actual highest index? I only have 10 entries. Every array starts at index 0. So what's the highest index? 9. Sir?
In a previous class, didn't you say the last character of a string was always the null character? So is there technically a number
We're not
10?
talking about a string here. We're
Okay.
talking about a character array.
Okay.
Character array isn't necessarily a string,
Oh, okay.
but a string is always a character array. That is why I less than 10 works. Okay? This is important. This is very important. These are boundary conditions. Boundary conditions are very important in programming. Okay? Because it's the boundary conditions that are going to be the things that kill you. It's the boundary conditions that you're going to have made assumptions about that are wrong. And they're hard to see and hard to figure out. That's why I went through the exercise of writing 0 to 10 here and then counting them. Because if every one of you hasn't gone through this exercise, I guarantee you'll make mistakes. And you'll still make mistakes. Some people will come up here and they'll put less than or equal to, and their program will be wrong. And it will not obviously be wrong. Because what it means in C is that you'll be stomping on some piece of memory that isn't yours, and you don't even know it until sometime later in the program when you try to access that piece of memory you stomped on and it has the wrong value. But back to what we're really talking about, for loops. This is what for loops are used for. Looping through something. Now this is something trivial, but you still have to do this sometimes. Okay? There are slightly easier ways in library routines to do it, but you have to understand what the library routine is doing underneath. Underneath the hood is what we call it. Like when you have a car. Right. How many of us know what goes on underneath that hood? Almost none. Well, one guy. Almost none. Two guys. Almost none of us know. Sorry. Did you have questions? Or were you saying you knew what goes on under a hood? I know what mostly goes on under a hood. Okay. For loop. Questions? Remember, implicit homework. Just because I've gone over this and shown you one example, that's all this is an example. There are other ways to use for loops. The increment doesn't have to be by 1. The increment can be a different condition. The increment can be while some character array is not equal to some value. The stopping condition could be any sort of complexity you want. In this class, we won't do anything terribly complex, but you have to understand how a for loop works. Any questions about a for loop so far? Okay. Second person in the second row. Why do I have single quotes around that A instead of double quotes?
This is a singular character.
This is a character. It is not a string. It's just getting a little review in while we're at it. Now suppose the character array C had been previously declared and initialized, and I was just initializing part of it. So suppose I wanted to only initialize part of it. Okay, third person in the second row. Apologize for my writing in advance, but this says if character array C sub I plus 1, in other words, the next character, is equal to, double equals, backslash 0, which is the null character, right? So in other words, suppose I'm only trying to initialize this string, this character array, for what may be a null terminated string. That's what this does. Okay. What do you think the break does? If this is true, the break will happen. What does the break do you think?
I'm not sure.
That's okay, I haven't told you. It exits the loop. That's what break does. It exits the innermost loop. Suppose this for loop was nested in multiple loops. Suppose it had 4, 4, and 4 outside of this. Break exits the innermost loop that it is in. And then continues with the next statement after the loop. And by the way, that applies to all loops. Do while loops and while loops. This is how the break works. Okay? So that's what break does. It exits the innermost loop. That is key to remember those words, innermost. Because you will often enough find nested loops that you need to do what you're doing. What do you think the word continue does? Okay, let me add to this program. Suppose I add to this program after that if statement, I add C sub I gets B instead of A. Now, if I encounter the null character, what does this continue do? It continues the loop. It skips whatever is below it and goes right back up to the top of the loop, which executes the condition test, executes the increment, and then continues on. That's what continue does. Continue says, skip the rest of the code in the loop and go back to the top of the loop. That's what continue does. For all loops. For while, and for do while.
Oh, did you say that the continue word skips through the loop and then goes back up to the top?
It skips the rest of the code in the loop, whatever it may be, and goes back to the top of the loop. And every time you get back up to the top of the loop, you execute the increment, and then you do the test. That's why they're in this order. Initialization, test, and increment. The way they document it, they say the increment happens at the end of the loop, which is really true, but since it's written up here, you could think of it as the next thing at the top of the loop, except for the first time through. But in your implicit homework, you will look it up and you will read it carefully and you will come to understand it. Every time I write a for loop, I have to pause and think about it. That is just one of my deficits. This is one of my assumptions that I will get wrong if I don't pause and think about it. Personal, right? We will all have our personal things that are just blocks in our brains for some reason. A neuron died and you never got it back, whatever it is. That's just one of mine. And I never get for loops wrong, but I always pause and think. I'm a thoughtful programmer. In some programming classes, you'll hear guys typing real fast. Ignore them and know they are doing it wrong. I guarantee it. Because they're impressed with the clatter of their keys. Right? They are not thoughtful programmers. I clean up their code all the time. Clean up their code. I tell them why their code is wrong all the time. And I tell them, slow down and think. They usually don't, which means the third time they come and ask me, I'll say, you didn't slow down and think. Go try it again. And then they'll go ask somebody else, but I've accomplished my goal. They will either have slowed down and think, or they won't bother me. Either way, I've accomplished my goal. And then the boss comes and asks me, well, I see so-and-so asking a lot of other people questions all the time. What's that about? To which I say, I don't know, because that's the true answer. I can only tell you the kind of questions he asked me about. And then that's very little, because he doesn't ask me many questions anymore. And then the boss will make of that whatever they make of it. I see the results, so I usually know what they make of it. They usually go ask some other people, who may or may not give them honest input, but the result ends up being the same, because the person ends up not being as productive as he should be, or she should be, whoever they are. So, stop and think. That is the key to programming. Slow down and think. Do I write a lot of code quickly? Yes, but I've been doing this for decades. Okay, that's the for loop. Any questions about the for loop, break, or continue? For now, unless I tell you otherwise, assume you can do this, because I'm pretty sure you can. And it declares I, which is limited to the scope of this loop. Declares it in the code itself. In the code where? In here?
Inside.
Inside of here, it wouldn't be valid outside here. In other words, if you put int I here,
No, if we put inside above full.
above it,
Yeah.
and then you said int I here,
No, just, without.
you said I, just like I had originally done it,
Yes.
it's fine, same thing.
What if in the case scenario that you just said, like a second
I
ago,
declared int I here, and int I right here,
if we put out above,
oh here, you get a compiler error.
what if we put it both?
You get a compiler error. You cannot declare this, the same variable twice where it is ambiguous. Which is what I was about to get to, scope. I've used the word scope without defining it, right? Someone should have raised their hand and said, what is scope? So since you all know what scope is, who wants to raise their hand and tell us what scope is? I assure you, if you cannot question me, it is very unlikely you will be able to question yourself. Scope. Raise your hand.
No, we said raise your hand if you want to know what the scope is.
Okay. Who wants to know what scope is? Scope? How do you define scope? Think of scope as the ability to see something. So if you're inside your house, right, what you can see of the street outside is limited by your windows, doors, whatever you may have, okay? If you are in the front yard, the amount of the street that you can see is greater, okay? So that is what scope is. It's what you can see. Okay? Scope is basically defined by braces. Braces define scope. Now, strictly speaking, braces just define a compound statement. Compound statement is multiple statements, hence the word compound. And the braces define what's together. That's what braces actually define, is a compound statement. That could be a single statement. It can even be no statement. It's perfectly valid. But in addition to that, it defines scope. So if you declare something inside the braces, nothing outside the braces can see that variable. So suppose I declare in here, which is perfectly valid to do, int j is equal to 3. If I tried to say printf, okay, I would get a compile error. Not because it's anything to do with printf, it's at this point in the program, j has gone out of scope. You went out of scope at this brace, therefore the compiler will not know what j is. compiler will say undeclared variable J, or something like that. Okay?
In order for it to be declared, we have to open another brace for that, right? For
Another brace where?
on that side.
You mean
Since
like
you said
this?
it's out of, since you said it's out of,
You mean
yeah.
like this? No. That's a whole nother scope itself. We can't see this.
Can we just take out the brace, the census C out?
We're not gonna do what if,
and then put it
I'm
on?
defining scope. You can't do what if. You can't program by what if, okay? You have to program by knowledge. Scope is contained by braces. Okay? If it's declared within the scope, it cannot be seen outside the scope. If it's declared in a higher scope, it can be seen. So suppose up here, there's another brace for whatever reason, and I instead declare J equal to there. I can see J now, because it's within the scope of these bigger braces. Now here's the next question for the fifth person. The fifth person. Inside this loop, which is also inside this scope, can I see J?
No.
Suppose I put a reference to J there, right? Inside this loop, inside this scope, which is inside this scope, can I see J? Will this be valid syntax? 50-50 chance.
No. Yes.
Yes, why? The why, have you noticed the why always follows? Why? That's correct, why?
Because this loop is within the first braces.
That's because anything within this scope of these outer braces can see J. The fact that it's an inner scope, it is still within the scope of these outer braces, so therefore it can see J. So explicit homework, go look up scope in terms of the C programming language. It will be in your book, it will be in other references. Look up scope and read about it. It will have good examples. I've made quick examples, but it will have more examples. See, this is what I actively have to do when I teach. I have to remove assumptions. Fortunately, I'm fairly good at it. Unfortunately, it means I digress too often, which is not a good teaching technique. I should have perhaps had a whole section on scope before we got to loops. But we got to it eventually. Look up scope and have your questions ready next week about scope and what it means, if you have any, and what you find is not clear. Okay, any questions about for loops, break, continue, or scope, or what scope means? Sure.
That right there under break and continue says go to. Is that the scope they're talking about?
No, that's the subject.
Oh,
That's the next subject that we're actually not going to talk about. We're going to talk about it, but in a negative connotation. Questions about for, break, continue, or what scope means? Okay, go to. The brief statement about go to is do not use go to. You have other instructions such as break, continue, and return. That will take the place of go to. Go to should never be used. You will get a 0 in this class if I ever see you use go to. Should never be used. You will have a very small minority of people that will disagree with me about that. I had an architect disagree with me in a room full of people. that architect lost all those people's respect. Because all those people knew that. I didn't even need to continue the discussion. I just, okay. Because I knew what had happened with the rest of the people. I didn't say another word. Two reasons. One, I knew what had already happened. And two, it would have been pointless to say anything else.
Why should we consider?
The same reason you should always use braces. Because if you use goto, your code becomes less clear and more prone to error. That's the compelling reason. And the mitigating reason to never use it is that you have these other language constructs like break, continue, and return that will allow you to write clean code. In fact, there are people who will say you should never use break and continue. There are people who say you should never use return, which you haven't talked about much, but except at the end of a method and never in the middle of a method. Those are people who also believe you should never use goto, but they're carrying it to an extreme. Because break, continue, and return really are goto statements. In the generated assembler, they're just like goto statements, except they are very well defined. That is why it is, in my opinion, it is okay to use break, continue, and return. Because their actions are very well defined, your code is clean and clear. There's no question what will happen. But when you start using gotos, you end up with something often called spaghetti code. And spaghetti code is, you ever tried to untangle spaghetti? That's why it's called spaghetti code. Question?
You answered my question.
Never use goto. Never, ever, ever. In C. C++, C#, Java. Now when you're writing an assembler, and you may have to take an assembly language code, you will have an instruction in assembler called jump that you have to use. Because that's what gets emitted for break, continue, and return. Is a jump to a particular place. Don't worry about that when you take assembler. For the purposes of all programming languages, really. Even the scripting languages. Never use gotos. They all have better constructs. I had to think about it for a second, but they all have these better constructs. Now some of the older languages, like COBOL, Fortran, Algol, Pascal had. Those three, they didn't have these convenient constructs. So these are older mainframe languages. So people had to use them sometimes. But even then, I never used a goto. Unless I was fixing somebody else's code where there was no choice. But in code I wrote, I've never written a goto in my life. But I've debugged a lot of terrible code that was full of gotos. This is wisdom. This is deep wisdom. Okay? I'll just tell you that right off. This is wisdom. Wisdom that people will choose to take or ignore. Arrays. Let's talk about arrays. Okay, so this declares a character array with 100 characters. If I'm going to use it as a string, that means I can only have a string of 99 characters because it has to have a terminating character of a null, \0. Now then, so this is an array. This is a pretty simple array. When you have an array, if I do that, if I use an array name and do not give it an index, it is by definition a pointer. Remember when I told you pointers and references are going to be important? Because they are. They're going to be involved in almost everything you do for the rest of the class. So, if I declare a pointer, in this case I called it pname, and I just assign it to name, it's a valid pointer to the array called name. Interestingly enough, a pointer you can index. If you index that pointer, as long as it's a pointer to an array. Actually, you can try to index any pointer, and the compiler will assume you know what you're doing in C, and go ahead and do it. That's why you can write a lot of code in C that doesn't work, and there's nothing obvious that the compiler tells you why it doesn't work. This is why you have to understand. This is why you have to understand how all of these things work, or what they mean, and why they work. Sixth in the row. Is that statement going to be true or false? The pointer to pname is pointing to the array name you declared up here. These are the exact same locations.
Oh, okay. So yeah, it'll be true.
So it'll be true. Because these are the exact same locations. Okay? I've declared a pointer to that array, assigned it to that array. I've declared a pointer, I've assigned it to that array. I can't declare it twice. Those two are exactly the same statement. This is why you have to understand pointers and references. Okay? I've declared a pointer simply by the conventions of the C language, not conventions, the rules of the C language. An unsubscripted array is a pointer in and of itself to that piece of memory. But if I subscript the array and then get a reference to it, it's the same thing. It's a pointer to that piece of memory. And this is what you have to understand to fix all the questions you've brought me in the last 20 minutes. They're all flavors of this same question. Once you understand this and understand it correctly, it'll answer all your questions when you set about removing your assumptions. Any questions about why those are the same? You'll probably have questions. Go home, read your books, look up references, understand why they are the same. Understand why this if statement returns true. Because an array is a pointer all by itself when you do not subscript it.
So when you said all strings are character arrays, but not all character arrays are strings, is it just the presence of the null character at one of the indices that changes it, or are there other variances?
Suppose you're putting just numbers into the character array. Because remember, characters are numeric variables. They're integers. They're short. They're not even short. They are 8-bit integers. Okay? That's why you use single quotes with them. Now, as it happens, you most often put ASCII characters in it, and most often they are strings, but not necessarily. Suppose you're reading binary data over the web. You're going to put it into a character array more than likely. And it's binary data. It is not strings. Binary data. That happens all the time. In fact, every time you enter something into a website, that is exactly what's happening. Some binary stuff is being sent. Because it's not just the characters, it's all sorts of control codes around it. Some of which are characters, some of which are not. I mean, readable characters, visible characters, some of which are not. And then that character array that has that entire binary string in it, some of which is readable, visible characters, has to be decoded by a program. And that's what is actually going on in the real world. But most often in what we do, a character array, as you say, will contain a string. Instead of visible characters, terminated by a null. The null is how you know where the string is. So, in programs where it says, read a name, take an input of a name from the keyboard or whatever, however it phrases it. Next person to answer the question, who is it? By the way, who's ever heard of the phrase, okay, boomer? Most of you guys think you're insulting boomers. Boomers consider it a compliment, by the way. We actually consider it a recognition of your youth and ignorance. But we consider it in a complimentary fashion towards ourselves. Okay, you have to take in a name in one of the programs. I forgot which program, program 1 perhaps. So you have to declare an array, a character array to hold that name, right? So what kind of array do you declare?
A character array?
Character array. Just like this, char name 100, okay? But you may have to declare in a later program multiples of them. So how do you do that? How do you declare, well, I think in the case we're talking about, you have to take in 5 names. So you need 5 arrays. So you could, right, perhaps in the first program, say, char name 1, char name 2, 100, so on, until you have 5 of them, right? You can absolutely do that in one of the programs. I think in the following program it says, okay, you have to use a for loop to make it a 2-dimensional array or something. So the question is, how do you make it a 2-dimensional array? So it's actually fairly straightforward, if I remember the syntax correctly, which I may or may not. Because you're going to get multiple names, the appropriate meaningful name is names plural. And let's suppose you want 5 of them, each with 100 characters. You declare something like that, if I remember the syntax correctly. It's either that or 5 comma 100. I think it's that one. Yes, sir.
Does it have to be a pointer? For
That's
this?
not a pointer.
Okay.
That's a 2-dimensional character array. Now, when you come to use it, the pointerness is going to become meaningful. Now, let's talk about why that pointerness, or having it as a reference, which is what a pointer is going to become meaningful. Next person. Because to get the input, you're going to do this. Scanf. And what format specifier are you going to use?
Would it be %C?
Percent.
No. What is, okay, that's a good question. What does %C do? What is %C expecting for input?
It's expecting a character.
One more time?
A character?
How many characters?
Just one.
A character, which means 1 character. And most of us have multiple characters in our names, right? I know a person or two that actually has a single character for their name, but most of us have multiple characters. Okay? So therefore, we know it's not going to be %C, because that's a single character. So what's the format specifier for multiple characters, for a string?
Not too sure.
What's the format specifier for a string?
%S.
Yes. Turn around and say thank you.
Thanks a lot.
Turn around and say, don't do it again.
Thank you again.
%S. Okay, that's the easy part. It should have been the easy part. Okay. Next. What's this parameter for scanf? No, I mean, sorry. What type of parameter does it need to be? One more time? A string? No. What type does it have to be? When you were doing this, and you said char C, and then you said scanf, what did you have to put here? Let's call it letter instead. Okay, when you were scanning C, what was the next parameter you had to put? You had to put what here? Ampersand. Why? What do those things mean? Ampersand does what? Yes, it points to the location of letter. This is a reference. That's what the ampersand does. Apologies again for my writing of ampersand like this. That's what ampersand does. It says a reference to letter is what you were passing. Because some of you wrote the first program and you didn't have the ampersand and your program didn't work. Because it wrote it off into some random piece of memory. And then when you printed out letter, it printed out something other than what you entered. That's why you had to put a reference to letter. So what this is actually putting in is a pointer. A reference to something is actually a pointer. Okay? So, to do a string, we've already decided that a string is contained within a character array, terminated with a null. So to input a string, who's next? We'll go with you. To input a string, what kind of reference do you have to put here? What kind of pointer do you have to put here? Not a string. String is meaningless. There's no such thing as a string in C. String is only by convention. Okay, so suppose we're not doing that anymore. Suppose we're doing so we have a character array, which is the convention used to create what is loosely called a string. Okay? What do we have to put here? This is a piece of memory, right? Char name 100. Piece of memory, where does it happen to reside? Does this reside on the stack or on the heap? 50-50 chance. Heap? Why? Because this is not a fixed length. It's a variable length. The fact that we put 100 here, we could have put X and then declared it with X. It's a variable length. So anything that's variable length goes on the heap. Well, that's not entirely true, but for most purposes it's true. So it goes on the heap, but it's a piece of memory. How do we tell scanf to put some string into that piece of memory? Reference to what? Okay, a reference to name. What is name already? Name is already a reference. It's already a pointer. So you could, that's the simplest way. It would also be perfectly valid to give it a parameter of a reference to name sub 0. Because name by itself, name is an array, name by itself is already a pointer. It's like we talked about over here. Okay? Name sub 0 is a particular character. It is a particular character that happens to be at the very beginning of this array called name. So if we give a reference to that particular character, it is the same as the pointer itself. Who thinks there's going to be questions all about this on the next exam? Who thinks the next exam might contain at least half of the questions of this nature? Cannot stress to you enough the importance of understanding pointers and references. Is it natural and intuitive? Not necessarily, but you do have to wrap your head around it.
So you declared the char name individual arrays before the multidimensional array, but if it's not a jagged array because you're declaring the 100 formally, do you have to make all the declarations beforehand? Because, like, why would
We're
you
not
need...
interested in jagged arrays.
So I'm saying because it's not a jagged array, why do you need to make all those declarations before the multidimensional array declaration? Like,
You
are
mean
the
these?
top line... Yeah, like...
They weren't. This is one way of doing it, this is another way of doing it.
Okay. Just making sure.
Should you make something a reference by adding the ampersand sign to
Yes. So when you did this, you were creating a reference to a reference, which is valid in some circumstances, not this one. It is perfectly valid to have references to references. So for instance, let's suppose we've moved on and we've done two-dimensional arrays. And you're going to want to input one of these 5. So let's go to the next row on the side. So names of 5, you've allocated 5. What are the valid indexes of this first dimension? Yes. What are the valid indexes of this first dimension? 0 to 4, that's right. So, let's just say we want to input the first one. So we want to use name sub 0. Next person along that row. What is name sub 0? Is it a character? Is it a character array? Is it a pointer? What is it? What type is it? Based upon this. Oops, sorry. Names plural. It's a reference? Reference to what? I'm sorry, who's answering? I can't hear you. Back in the back? Okay. What do you think is a reference to? What is it pointing to? You said it's a reference, that means it's a pointer. That's true. What is it pointing to? It's pointing to these 100 characters associated with index 0. Now, when this thing gets allocated by 100, it depends on the operating system how it actually gets allocated. But when you reference it, the reference is consistent. Name sub 0 is a pointer to the 100 characters associated with it. Name sub 1 is a pointer to the 100 characters associated with index 1, which is different from index 0. The people who were asking me why this didn't work, hopefully you now understand why. Because it's the same thing in the multidimensional case. You have to pass it name sub 0 and you still have a pointer. And that's where it's going to put the data that it reads in via the scanf.
So array 5 is just pointers, right? So that's why you can't put data there.
One more time?
So array 5 is just full of pointers, so that's why you can't put any data in array 5.
You mean names sub 5?
Yeah.
Names sub 5, no, you can't put data into it, but you have to treat it as a pointer. If you do, so for instance, suppose you came down here and you said scanf %s, which says read a number of characters terminated by a null or terminated by the key enter on your keyboard. Same thing. Alright, names from 5 is not valid, let's use names from 0. That's valid. That would read a string into the first index of names of 5, 100. Because the data is actually going into the 100 bytes that's associated with index 0 of that array.
But you can't put it into the 5 array itself and not the 100.
You mean if you just said names here?
Yeah.
Names is a pointer, but it's a pointer to the array of arrays. That's what a two-dimensional array is. Okay? Let's talk about what a two-dimensional array is. Okay? Names is a pointer to an array. In our case, we've said that array has 5 entries. So it's simply a pointer to an array of 5 entries. This is not an array of characters. It is an array of pointers. And those pointers point to other pieces of memory where the actual data is. Okay? This pointer points to another piece of memory that holds the 100 characters, 0 to 99. This is how the memory actually looks. Okay? So that is why names by itself is a pointer to this array of pointers. Each of the pointers in that array points to another piece of memory. In this case, 100, because that's what we declared it, 0 to 99. That's why names sub 0 goes to the array called names, indexes it for 0, and gets a pointer.
If we change it into names sub 1, it would go to the same amount of points. Not same.
Some other chunk of memory is pointing to.
Not pass 4 though, right?
Sure you can. You can index it with 5 and it'll stomp on some unknown piece of memory. That's one of the problems with C. Problems, using that word loosely, when you know what you're doing, you get a performance boost because you're not doing range checking. Range checking means the compiler has to emit code that says, if the index you gave me is greater than this, and you have to do it on every access, that's a performance hit. Think about poor Neil Armstrong trying to land the moon lander, right? But that performance hit. He already had a performance hit. 1401, what does it mean? Can't process the data coming in. That's what the 1401 error was, or maybe it was 1402, on the moon landing. That's what it said. He said, I cannot process this data fast enough to give you a meaningful answer. So what did poor Neil Armstrong have to do? He had to look out the window and eyeball it, and miss boulders and craters and land that thing, because the computer couldn't keep up with the radar information coming in. That's why those kind of decisions were made in C, because back then, performance mattered. Because if you look at your phone, you just want to say 1, 2, 3 gigahertz processor speed, right? That's what your phones, your computers, they all say that. That's what your chips do. Back then, we were running in the kilohertz range. That's 1,000 times, no, that's a million times slower. And back then, we were happy to be running into kilohertz, okay? Didn't help poor Neil Armstrong, can't process your radar data fast enough. Good luck. Except they didn't have enough memory to contain the words good luck, so he just had to do his best. And he did. As opposed to these clowns trying to launch Artemis 1 now. No, I would not call them a national embarrassment. I would call them an inevitable bureaucracy that happened. Okay, that's commentary, not part of the class. When's the next try for Artemis 1? September 23rd. 3-something a.m. our time. Okay? This is what two-dimensional arrays actually are. They are, the first dimension is a pointer to an array of pointers. Each of those pointers, because it's two-dimensional, points to real data. So therefore, hang on, I'll come back. When you're figuring out what to pass to your scanf, and that's what a lot of you are trying to figure out, you have to understand what this means and pass the right thing so that it's actually the correct pointer to this piece of memory you're trying to put the data in. And then later on, you have to figure out, how to reference that data correctly in printf or whatever you're using to print it out. That's the challenge you have to overcome. Sir.
Are all of the arrays kept in a heap? Or is the
Yes.
array of pointers in the, okay, they're all-
These are certainly in the heap. Yeah, that's in the heap too. Yeah, well, here, let me give you the correct textbook answer. It is implementation specific and may vary from operating system to operating system and compiler to compiler. In reality, yeah, these guys are in the heap. But it's implementation specific. So it doesn't have to be, because there are computers that are not dynamic memory computers. There are computers, and the computer on Apollo was a computer that was not dynamic memory, it was fixed memory. They didn't have the concept of stack and heap. They had,
everything was all in
they
one
had,
space.
this is allocated and it's here. This address was fixed, okay, back then. Now, there's still some computers like that, but very few and very special purpose. For our purposes, yes, they're all in the heap. But names itself, this guy, which is a pointer, is going to more than likely be on the stack. It depends on how you allocate it, because it doesn't look like you want to get the malloc at 3. But if you allocate it by declaration, like this, it's going to be on the stack. Okay, now it's way past my bedtime. Any questions? This should be enough to get you through program 1, quite possibly program 2. All right, that's it. Have a nice evening. I'll make every effort to do that.